Your PDIM line, keep in mind that it's at 0 volts, which is global dimming, and your control lines for your local dimming are open, and there's nothing coming out of the main board to control them or the T-con. This unit does not have a T-con, but some things that can affect whether you can properly load the power supply is going to relate to local and global dimming and the control lines for those. Okay. Now we see that our LED is blinking because what we do not have is we do not have any dimming information coming to the power supply or the inverter, and so it's letting us know that that dimming information for PDIM is absent. Okay. Now what we've done is we've eliminated part of our power supply, and what we know is if the power supply is told to turn on, it will generate the voltages and it will regulate the voltages. Our inverter, if it's told to turn on, it will, and it will generate, and it's loading down the power supply, forcing it to deliver current. And the voltages are still being regulated, even loaded. Keep in mind that if we have problems with local and global dimming information, then it may still require that a switch mode power supply be replaced. Under this condition, we can state that our switch mode power supply is functioning properly. If the load is incorrect on the inverter, as far as the LEDs, if one side of the panel is lit, the other side is not illuminated, or if there's a vast difference in how bright they are, you're going to get a feedback error, which the inverter is constantly reporting the load that it's under. So if you have a defect on the inverter, it can create a problem with one half of the panel versus the other. Since it's part of the power supply, we did need to bring that up and discuss it. Many of our power supplies have the inverter embedded as part of the switch mode power supply. These have their own power supplies. It's not necessarily 24 volts. Those voltages vary tremendously. The best idea with those is to look on the switch mode power supply for a screen print indicating the size of the television and what voltages that you will get. It will be a small chart on there telling you what voltage range you should get out of the inverter circuit going to the LEDs and the backlight circuit. When you have a separate inverter, the same scenario applies. When you have separate drives coming out of the inverter for different section of backlights. Now what we're going to do is we're going to utilize another television and demonstrate how the dimming circuit can affect whether your backlights load or do not load the power supply. When the backlights don't seem to come on, it's usually going to be because of a dimming control failure. And what we'll do is we'll show you how to defeat that failure by disconnecting your dimming control. What we're going to demonstrate now is the dimming control and how it affects the output of the inverter when we have a separate dimming control line coming from either the main board or the T-con. There are two different ways the dimming control can be affected. One, the inverter may output a voltage and either your main board or your T-con can create a ground bias control for that voltage. Let me explain how that operates. When this generates a voltage and outputs it to the line, when there is no video information down here, then these boards can actually default to pulling those voltages low. When that occurs, it's telling the inverter to dim the backlights because there is no video information. So when the backlights come up, they actually come up to only about 2 to 5% of their brightness. To you as a technician, it looks like the inverter is not driving the backlights. As a brief note, with a lot of our newer inverters, just because there's voltage coming out of the inverter does not mean that the inverter is running correctly. Example, if it takes 40 volts to power up the backlights because of the grouping and type of LEDs that's in the panel, to actually shut that inverter down, all we need to do is reduce that voltage to around 36 volts. If no LEDs are being forward biased to allow current to flow, your current draw is actually 0. So just because there's voltage coming out of the inverter does not mean that that voltage is correct. It may just drop below the threshold to where no LEDs are going to be turned on. And that will result in no load to our switch mode power supply. Now the same concept applies in this as it does the other, except for our dimming information is actually coming out of the T-con. When we open up this conductor from the power supply to the main, then our main has no power, no video is getting processed, nothing is going through the LVDS cable, including the 12, and our T-con board has no power, so it's producing no signal control for your dimming information. Now the same jumpers will be installed from your standby supply to your power on. Then we check our voltages, including starting with checking standby, just like we did in the previous unit. Then what we'll do is we'll add another jumper to tell this inverter to turn on. Then we'll see what happens when there is no video, no control information, and how it affects this inverter and how we can defeat that. Okay, so I'll quickly install both of the jumpers so we can get to that. First thing we're going to find is our standby, which again, we only have 2 pins. Now when we supply power to the power supply, we want to check and make sure that, number 1, our standby voltage is still present. It is. Now we need to find our other voltages, because the last thing we want to do is expect the inverter to come on if we're missing our 24 volts or if it's running excessively low. So we have 12 volts and 24 volts going to the main board, and we have another 24 volts here. In some power supplies, both of those 24 volts are generated off of the same transformer. In most cases they are. But you may want to check it in both places and check your fuse on the inverter. So we do have our 12 volts, it's running 12.1 volts, and we do have our 24 volts running 24.7 volts. Now we check here at the fuse, we have our 24 volts, so we know we have our voltage going to the inverter. Now, we want to create a load on the power supply by forcing the inverter into an on state. So we'll remove AC power, install the other jumper from another standby pin to the inverter on, or in this case it's labeled drive on. Now when we view through the holes in the back panel, it looks like our inverter is not running. So the first thing we want to make sure of is that inverter on is not shorted to ground and it took out our standby voltage. So we check and see if our standby voltage is present. And it is. We can also check our inverter on line coming out of the power supply and going to the inverter, whichever one is easier for you to check. Now it appears that our backlights are not working, so we may determine that our inverter is not running. Our dimming information, as I pointed out earlier, coming out of the T-con going to the inverter, is the lack of video is actually telling the inverter to turn the backlights down or off. The easiest way to defeat this is to open up this connector where we get our dimming control information from the T-con to the inverter. When we do this, the inverter is actually going to default to full brightness. Now we see our backlights are on and fully lit. What we want to do now is make sure that when we look from the front of the television that they're even going across. This is also another way that you can check for light leakage as well. Okay. Now we have a load on our power supply from the inverter and the backlights. We want to again check and make sure that our 24 volts is being regulated. We start with our 12 volts is running 12.5 and our 24 volts is running 12.2. Now we've tested our power supply and we've used the inverter and the backlights to generate a load on that power supply. Our switch mode power supply seems to be working properly. If you have an older or one of the differently designed units, you may have an error line coming out of the inverter and going back to the power supply or to the main board. In this test condition, no matter what the chassis is, look at your screen print here and see if you have an error line. If there is an error conductor, check and see if there is DC voltage on that error conductor. If there is, then the inverter is reporting either to the power supply or to the main board, depending on where it goes, that there's an error with the inverter. If there's voltage on that error line, then it's going to create a shutdown. If the error goes all the way back to the main board is going to shut the switch mode power supply off as a response to the error in the inverter. If the error line goes back just to the switch mode power supply, not to the main board or the power supply is going to respond to that voltage by turning itself off. If it does not go back to either one of those boards, then there is an error where the inverter is monitoring itself and will shut down as a response. Many times it can be a response to a startup problem on the inverter or a very imbalanced load on the inverter, such as too many bulbs not working if it's fluorescent, or too many blocks of the LEDs inoperable. There are cases where there is an error line and it's not used. As an additional note, before we're finished, many of our product has training manuals developed on those products. There are a few that do not have any information on them, but for the most part, we have information on conducting this test by model, and it's up on GSFS. If you can't find the information you need on GSFS or from technical support, please contact the training department. If we have access to the information you need on the specific model, we'll be more than happy to provide it to you. That should conclude us testing a switch mode power supply. Other than utilizing the test jig for models, and these type of tests should go back as far as you need to with older LCDs and with brand new LCDs as well. I thank you very much for your time, and I hope this helped. You have a good day.